Hello everyone. First of all, we would like to thank all of you for selecting our project in top 20 and giving us further opportunity to demonstrate our skills. Now we will focus on the demonstration part of the project. First, let me brief you about all the components that we have used in our project and the connections, respective connections. First, this is digital oscilloscope, which is used to display the PN sequence which is obtained from the transmitter side. This is the function generator to obtain different data rates which is fed to the transmitter as an input. Now this is the transmitter side and this board is for use for at the receiver side. The yellow wire indicates the input from the function generator. Now the red wire over here indicates the PRBS output from the transmitter, which is then fed to the receiver. The green wire indicates the clock cycle, which is is used for clock, which is transmitted from the transmitter side and fed to the receiver. Now let us shift our focus on the transmitter side of the bird. Initially we are providing data rate of 1 MHz. Now I will explain you the function of every switch at the transmitter side. First, these 5 switches are used for introducing the value of n. In our project, the value of n ranges from n equal to 4 to 24. Right now we have not selected any n, so it will indicate that it is necessary to select the value of n greater than 1. Now we can select different values of n by using these switches. Right now n equal to 24. Now when the value of n goes greater than 24, it will again show the message that it is necessary to reduce the value of n from less than 25. Right now I am setting value of n equal to 4. Now these 3 pins are used for introducing the errors. In practical use, a modulator is provided at the transmitter side and demodulator at the receiver side. A device which is to be tested is kept in between them. So when no errors are introduced, it indicates that our device is ready for the practical purpose, and it will display that no error is introduced. ERN indicates that no error is introduced. Now we can introduce for the testing purpose, we can introduce our errors manually. Right now I have introduced error number 6. To find out the value of error, you can refer the report. I will show you the output of PRBS from the transmitter. Right now I have selected n equal to 4. So at the receiver side I am applying this pin which goes to the input of the DSO. This indicates the PRBS output for n equal to 4. This is the output of this is a PRBS PN sequence for n equal to 4. Now I am selecting n equal to 5. Again I am running the oscilloscope. So this represents the PRBS for n equal to 5. Now let us shift our focus on the receiver side of the bird. First I will explain you the function of different switches at the receiver side. The first switch is used for copying the error rate. So to copy the error rate, we need to keep it high for at least 1 second. The second switch is used for stop bit. Sometimes there is fluctuation in the bit error rate between 2 different values. So to make it stable, we keep this high. Otherwise it is kept low. Now in our project we have a provision for storing 4 previous error rates. So these 3 pins are used for storing this 4 different error rates. This pin is used for switching between current error rate and the previously stored error rate. So when we want to see the previous error rate, we will make it high. Otherwise, to see the current error rate, we will keep it low. These 2 pins are used to select the particular error rate from the 4 previously stored error rates. Now I will explain the function, the display of different LEDs. This last LED indicates the sync status. When the locally generated PN and the PN received from the transmitter side are in synchronization, this will glow. Otherwise, it will not glow. These five LEDs indicate the errors introduced at different powers of 10. The first, when this LED is high, it indicates that the errors are counted in 10,000 bits. When the second one is high, it indicates that it is counted in 1 lakh bits. For the third one, it indicates that it is counted in 10 lakh, and the last one, it indicates that it is counted in 1 crore. The fifth LED indicates that the error is more than 10%. So when the errors are greater than 10%, the channel is not proper for the use, practical use. So and this indicates that we will have to change the channel. Now I will show you the total function of the transmitter and the receiver. Right now the value of N at the transmitter is N, 11. It is automatically detected at the receiver side. See, 11. Now I am going to change the value of N at the transmitter side. I have kept it 15. It will automatically detected at the receiver side. See, now it is 15. So it indicates that the value of N selected at transmitter is automatically detected at the receiver end. Now I am introducing the errors in the data. Right now I am introducing error number 5. For this error rate, for this introduced error, we will get an error rate at the receiver side. That is 2 into 10 raised to minus 6. You can see at the receiver. Now I am copying this error rate. I am keeping it high for at least 1 second. Now this one is copied. Now I am changing the error rate over here. I am making it 3. So for error number 3, the error rate is shown over here. See, you can see that for error 3, the value is exactly matching as shown in this table. Now if we want to see the previously stored bit, I am making this high. So this will show the error at error number 5. Which was 2 into 10 raised to minus 6. See, this is previously stored error rate. First error rate. See, it is exactly maximum. Now we have, this will show previously third stored error rate. We had selected this, we had stored this for n equal to 13, and the error was error number 4. As it takes some time to store the error rates, we had stored it previously. Now to go back to the current error rate, I am making it low. So you will come back to the error number 3 because I have selected error 3. It is exactly showing the right values. So this is the total function of our device. This way we can change the value of n from here. We can introduce errors as our requirement. The user can change the value of n, and the device will give out the error rates according to it.